Okay, so this is going to be our first problem. We're going to deal with a kind of a set of moving loads. The problem wants to determine the maximum moment at B, which is right out here in the middle, due to this kind of small truck, a two-wheeled truck. So the first thing I'm going to need to do is draw the influence line for the moment at B. Is that the same one you guys saw? I seen some perplexed faces.
What's that yellow thing?
I just something.
I didn't know.
I don't know. I'm a very poor artist. This would not be a good thing to drive your truck over. There's an expansion joint here that you can't see that protects it. So let's first look at the moment at, what did I call it? B. So let's draw the influence line for the moment at B. So I've got C, and I've got something happen here at B. So remember, we're going to come up here and we're going to put our fictitious hinge and put positive moment. So is B going to go up or down? It'll go up, and then the hinge will allow it to rotate, and we'll get a shape for our influence line, looks something like that. And just remember, these dimensions are 100 feet by 100 feet. So I need to find this value. That value is going to be a beam that looks like this. So it's a simple supported beam. The reaction here will be AY. Reaction here will be CY. And since I want this value, which just happens to be right in the middle, I want the case where the unit load is right in the middle. So I'm going to cut my structure there and look at the internal moment at B. You want to work the left side or the right side?
Right.
So we want to work the right side. So I need CY. What do you think CY is going to be? Should probably be a half, right? Well, let's just check real quick. So I'll say if I sum moments about A and make sure I'm in equilibrium, well, what do I have? Well, about A, the one force creates a negative moment with a moment arm of 100, and CY creates a positive moment with a moment arm of 200. Barely squeeze it in. So CY is equal to a half. And then if I cut the structure at B, I know my CY force is a half, and I'm looking for the internal moment at B. I'll draw my little unit load is still there, but it really is not going to make any difference. And this length is 100. So what's the internal moment? Well, if you sum moments at the cut, the internal moment is negative. CY creates positive moment, and CY is equal to a half, and the length is 100. So it looks like the moment at C is 50 feet. So now I can come back over here and say this is 50, and the units of my diagram are in feet. Okay? So that's kind of like a third of the problem. Now what do? Well, now I need to let my truck drive over from right to left and use this as my device to say when to stop it. So let's call this case 1. And that's where the first 2 kip force will go to the maximum value. So let me do a quick little redraw of the moment at B. And I'm looking at the combination where the 2 kip force is right here at the top, and then 12 feet back, not to scale, is the 5 kip force. So these are the values that I need. We already know this one is 50. What's this value? Let's just do a quick calculation. The slope of that line is rise over run. That's 50 divided by 100. So the slope is a half. So every foot I move, I drop a half. I move 12 feet, I drop 6 units, right? So this should be 44. So for this case, the moment at B for case 1 is going to be 2 kips times 50 feet plus 5 kips times 44 feet. So what's this? This is 100. This is 220. So 320 kip feet. Is that right? Okay. So now the second case, I have the same influence line for the moment at B. Let me sketch that in to keep track. You don't have to do it this way if you don't like. I like to do it just kind of keep track. So now the second force, my back wheel force at 5 kips, is at the maximum value. And 12 feet to the left, my front force has moved away. So now I need to know these values. Well, I already know the max value. It's 50. The slope on this side is the same. So again, move 12 feet. I drop 6. So this is also 44. So now the moment at B, say for case 2, would be my 2 kip force, bless you, times 44 feet plus 5 kips times 50 feet. So this is 250. This is 88. What's that? That's an odd number for me to try to add up. What's 250 plus 88 is 348? Oh, it's close. 338, and that's kip feet. So which one's bigger? 338. So the maximum moment at B is 338 kip feet. Questions? Okay.